Good afternoon, everyone, and welcome to the Construct Innovate webinar series on modern methods of construction. My name is Jamie Goggins. I'm co-director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. So this is our second webinar in this series, and the focus today is on designing homes for modern methods of construction. We're delighted that we have three excellent speakers this afternoon. So Aidan Ní Feargáil, who's the architectural advisor from the Department of Housing, Local Government and Heritage, and she's going to talk about why modern methods of construction is a key part of Housing for All delivery strategy. So as most people know, Housing for All is the government's housing plan to 2030, and it's a multi-annual, multi-billion euro plan to improve Ireland's housing system and deliver more houses of all types for people in the country. We have John O'Connell, who's engineering manager from O'Connell Construction, and he's going to reflect on why developers and contractors have moved towards modern methods of construction. And then we have Professor Brian Broderick, who is the Associate Dean of Research at the Trinity College Dublin and a Principal Investigator in Construct Innovate. And he's done a piece of work around the design for manufacture, assembly and disassembly, which he's going to present to us today. So without further ado, I'm going to hand over to Aidan for her first presentation. So over to you.
Thanks for that, Jamie, and thanks for the opportunity to come and say a few words. Yeah, I'm an architecture advisor in the Climate and Construction Innovation Unit in the Department of Housing. We work on a number of actions under the Housing for All plan. You all be familiar with, it was originally published in 2021, updated in November 2023 with 30 priority actions and 83 Tier 2 actions. The targets are as they were when it was first published in 2021, 33,000 new homes up to 2030. There's a 4 billion investment per annum, and the targets have been increasing. So just to give you a sense of the trajectory, the figures without brackets are the actual delivered or dwelling completions, in brackets are the targets. So we've had quite a good increase since 2021, when 20,000 homes were built or delivered, to 2022 is a good increase on that number. And we're expecting the 2023 housing completions this Thursday. The CSO published those, but the target was 29,000 and we should meet that. The target in 2024 is increased to 33,450 and up to over 40,000 in 2030. So the targets are increasing, and as you'll all be aware, they're expected to be revised upwards. There have been a couple of reports, and we are undertaking, or the planning division in the department are undertaking review of the National Planning Framework, and the Housing Commission report is expected shortly. So although we have been meeting the targets in the last couple of years, we will be challenged to continue that. So there are 4 pathways. The 5th chapter in Housing for All is around enabling a sustainable housing system. And section 5.3 is to achieve economic sustainability. It's identified that MMC is a key measure to enable productivity and efficient delivery of housing. And the original Housing for All plan identified that Department of Enterprise, Trade and Employment, supported by ourselves, would promote a culture of innovation in residential construction and identify the development of modern methods of construction. So I suppose why? Well, construction costs in residential construction accounts for about 50% of development costs, and there have been a number of good reports from the SCSI on housing and apartment delivery in recent years. The CSO, the Wholesale Price Index, indicates that while materials have now had quite a good, sort of a stable year up to November last year, there was a significant increase in the previous 12 months, and the costs are still high. And labour is also, labour costs are also driving costs upwards. So the SCSI Tender Price Index, which is published about twice a year, is indicating that the labour costs are still the primary driver for tender price inflation. That's for commercial construction, but would be similar, I think, for residential. Productivity in Irish construction has been reported as being low in terms of its comparison to other construction sectors in Europe, but also compared to other sectors in the economy. So another major challenge is the labour and skills shortages. There was a report in 2022 by the Department of Further Higher Education Science, Research, Innovation and Science on the construction needs for residential sector, and looked at retrofitting also, as well as general employment in repair and maintenance works. And they estimated about 50,000 new entrants were required into sort of the craft and managerial professional occupations over the housing for all period, and that this would be a combination of workers upskilling and also new entrants into construction. But just to give a sense, the total construction workforce in Q3 2023, and this is not only in housing, but all construction workers, was 167,000. Now that does exclude some of the professionals, but it is quite a significant challenge. These challenges aren't unique to Ireland. We have been speaking internationally with colleagues in the UK, the US, and in Europe, and you might be aware of some of this work. There is support through the Affordable Housing Programme for MMC through Homes England, and there's also an inquiry going on which may be of interest at the moment in the House of Lords. And I've just shown the definitions framework document that CAST Consultancy led on behalf of the Department of Levelling Up Home, Housing and Communities in the UK, which we have, I'll come on to, but and I know it's been covered in other speakers' previously talks, but the definitions framework for what we mean by MMC. But in Europe, there was a housing ministers conference just under 2 years ago. The industrialization, as they wouldn't necessarily use the term modern methods of construction, but it was one of the key items. And we've also been in contact with the Housing and Urban Design Department in the US, which are developing their own roadmap for modern methods of construction there, or off-site, as they call it. So there are more opportunities than simply maybe the cost and the labour shortage. And we've published a small guide which is sort of for a general reader, but sets out some of the opportunities and describes some of the categories. But I suppose these have been identified in reports, and the evidence is kind of bearing them out, but is being developed to support some of these at least. So the faster delivery construction program and potentially the overall development program. There is perhaps longer lead times or longer design times, but we are starting to see that there may be faster delivery overall, as well as in the construction phase. Lower construction costs in theory, based on economies of scale, repetition, standardization. We haven't seen that bear out yet, but there is some evidence coming through. Different and lower labour requirements. So I suppose that's an important aspect given the labour challenges, but it's not simply the lower labour requirement, but also so in terms of I suppose the labour force, perhaps bring new entrants if there's a different sort of working environment. If it is off-site in a factory, you potentially have a more fixed place of work, indoor working conditions. I suppose another opportunity, high quality, better quality control in a factory environment. And I know Martin spoke last week about the agreement, and I think there's good quality control procedures in factories, and then I suppose coordinating that with the on-site work. Efficient use of resources and tracking the use of resources, which can be done through more digitalization. You can have better data on what is going into the buildings and reduce waste and support the circular economy. So, you know, the Housing for All plan was published in 2021. There had been work done prior to that through the CSG, and there are a number of really in-depth reports which are available. You know, were commissioned by consultants, a number by the CIF. So just to give a sense that there has been quite a lot of work happening in different government departments and agencies and through the CSG. The Housing for All Industry Capability Working Group oversees the work that's being delivered by the different departments on the actions related to MMC and Housing for All. And I suppose I think I come on to the Modern Methods Construction Leadership and Integration Group, and more recently the Timber and Construction Working Group. So construction sector group and subgroup have sort of, I suppose, initiated many of the pieces of research and work around MMC, which were then incorporated into Housing for All, but they do have an increased focus on residential construction. The Modern Methods Leadership and Integration Group was formed by the Department of Enterprise, Trade and Employment in response to, I suppose, the ask in the original Housing for All to coordinate the activities around MMC in Housing for All. And one of the significant pieces of work they coordinated with ourselves and others was the roadmap for increased adoption of MMC in public housing delivery, which was published last July. There's 28 milestones, different themes, procurement, regulation standards, capital finance, insurance skills development, industry competitiveness and capacity, and policy execution and communication. So in terms of the most recent update, there are a number of priority actions related to MMC and many other so tier 2 actions. But one of the pieces of work we're currently developing is a standardized, so I'll come on to it in a minute, but a standardized approach to the design of housing to support the use of MMC and look at a number of aspects of that. There's 3 actions, priority actions related to the accelerated delivery of social housing, which is a program that commenced about just over a year ago, and then the National Demonstration Park for Modern Methods of Construction. And then I'll just mention a couple of points on this. The standardized design approach study arose from the residential construction cost study that was published last May. There's a industry government steering group in place, and we're looking at existing guidance around standardization. There's a publication on a design manual for quality housing that the department published for local authority housing deliveries, social affordable housing. The LDA has recently brought out an apartment typology booklet, but to look at house designs which would be optimized for the use of modern methods of construction, including layout, services and components, and we'll be going out with that project shortly. The Accelerated Social Housing Delivery Programme, say, was launched in December 2022. There were a number of exemptions and incentives to go into that programme. There is a sort of 2 working groups or management groups in place with the department, the Housing Agency, Local Government Management Agency, and the Office of Government Procurement, looking at procurement and local authority engagement. There are 34 sites to deliver up to 1,800 dwellings in 13 local authorities currently in the programme, with 6 regional frameworks, 3 of which are currently out for tender. And there have been ongoing workshops with local authorities, regional workshops, and the procurement guidance, which was published by the Housing Agency last April, which is guide for the use of the PW CF2 form of contract, which is design build or designed by the contractor, is being reviewed now to incorporate feedback. So just as an example, I suppose, in terms of going back to the opportunities of MMC, some of these are borne out in evidence. This is just an example of a number of projects that were evaluated in Wicklow County Council, which has had a design and build framework for a number of years. And you can see that obviously the delivery times are substantially improved in these example or sample of projects. The change orders are significantly reduced, which obviously has a resource and cost benefit. And then the final accounts are also coming in much closer to contract values than the traditional build. The demonstration park, another priority action, is co-located in Mount Lucas in County Offaly with the National Construction Training Centre, and there's been good progress. The master plan is agreed, the housing unit designs are agreed. A planning application has gone into Offaly County Council. A decision is due in February, and groundworks to start thereafter, with the park open by Q3 is the current projection. But just to say, there are quite a few other actions, and I won't go into all of these, but there's, we're looking at training for public procurers, which is linked to the workshops that are being done for the Accelerated Social Housing Delivery Programme. The building control authorities, we have an event in Athlone on the 31st of January, which we can share the information on, but it's a CPD day on MMC. And there have been a number of CPD training for professionals also undertaken. The RAI had a DFMA day in November. There's a study ongoing around the skills requirement for MMC. So there has been obviously work done on skills for the whole of residential, but now a specific skills study on MMC, which will generate an action plan on that. Excuse me. We're looking at we're carrying out a study on criteria that are used to support MMC in public contracts, and we're looking internationally at what other countries have done in this space. And obviously all of this needs to be underpinned by data. So there is a data project ongoing to have a better set of information to be able to track how the MMC sector is advancing in Ireland. Then there are a couple of other actions around pilot projects for 3D volumetric, and also the Timber and Construction Working Group has started its work. There was a first meeting of the thematic group 2 yesterday to discuss that is the regulations and standards working group of the main steering group. So I think that's it.
Right, brilliant. Thanks, Aileen. That's fantastic to see all the actions for the government departments to support the MMC sector and delivering housing in Ireland, and also see the progress. I mean, one thing is having actions, but actually to go and deliver on those actions and so on. Next we have John O'Connell, who's the engineering manager for O'Connell Construction. So I suppose he's on the ground actually building houses, and let us know why developers and contractors are moving towards MMC. So over to you, John.
Hi everyone. John O'Connell is my name. I'm the engineer manager for OCC Construction. We are an innovation-driven main contractor based in the west of Ireland. We use modern methods of construction to build rapid build projects across the residential, commercial, healthcare and hospitality sectors. So just a brief overview what I'm going to run through today. Why do we use modern methods of construction? What strategies we're currently employing, the challenges and learnings we've had to date, and I'm going to give a brief overview of a sample case study of a housing project we built recently in Galway. So from a cost control point of view, from the outset, as a lot of the detailed design is carried out before any manufacturer or any works are carried out on site, you've cost certainty, which is important for a developer when they're looking at the grand scale of things. You've decreased overheads generally, as the management required to put together all the components on site is a lot less, and the amount of time you actually are on site is typically between 20% less than a standard traditional build project. You've greater productivity and maximization of labor resources, because a lot of the work is carried out in a controlled factory setting, so you're not left with weather delays or anything else affecting your output at the end of each week. From a speed point of view, so as I said, approximately 20% time savings can be gained, which, just a pure example of this, block of 2 3-bed semi-detached units could be erected on site and roofed within a period of 5 days, which is good going in comparison to when you look at traditional built houses on site. Regarding quality testing and certification, this is a big item, as all the building components are manufactured within the factory. You'll have all your certification complete before anything gets manufactured, and your whole BCAR process can be dealt with at design stage, rather than it being pushed down to the end of the project, where traditionally the last month or two of the project for guys on site is nearly chaos trying to get over the BCAR line. So it's massive to get that out of the way early in the construction process. From health and safety, you've a lot less site activity, so there's a lot less trades interacting with each other on site. Simple things like the block layers on site and all the wet trades, minimizing them creates a lot cleaner sites and allows a lot more room on site for movement of prefabricated materials. But from a health and safety point of view, it also allows us to bring in the health and safety team at design stage, design out risks completely. So examples, this could be the handrails coming already attached to a precast concrete stairs, or window oaks already battened out, so it takes away the risk of falling at height. And a lot of these considerations can be taken very easily at design stage and incorporated in manufacturing in the factory, and it transfers to a lot safer sites for everyone. From a sustainability point of view, overall waste can be reduced by over 15%, but in theory on sites I think it's even a lot more. This is down to the optimization of your materials usage on a factory floor in comparison to all the trades looking after their own materials on site. But this also presents a different opportunity for us, is we can look into the embodied energy, embodied carbon for every aspect of your offsite component, because you can actually account for the labor and every component that goes in, every product that is used on the factory floor. So the output results of embodied energy and embodied carbon are very realistic in comparison to trying to calculate it when the project is complete traditionally on site. And another item there would be the project risk avoidance. So with a lot of traditional building projects, you will hit speed bumps along the way when you've designed trying to catch up with contractors on site. But when we bring that design stage and bring it to the very start of the project and try bring all the stakeholders together, whether it be M&E, whether it be input from your DocM and so on, if everybody's engaged for a couple of weeks at the very start of the project, a lot of these risks are taken away and allows for a much more smoother construction process. So I just want to hone in on the time savings in MMC. So we've been building with different aspects of MMC for the last 6 to 7 years, and we've used one prototype housing estate in particular to evaluate the use of, say, ICF, like edge steel and timber frame. And from this experience, then we're just looking at the time, where are the time savings on the program. So as you can see here in the top, we've what methods of construction optimized project, whether it be timber frame, like edge steel, or precast concrete. Your detailed design, your approvals, are all very importantly at the start of the project, similar to your traditional site build. But while you were carrying out all the site infrastructure works on site, such as foundations and getting all your site services going, the manufacture process is happening on the factory floor. This transfers to a shorter on-site assembly time, and again, you'll see the certification handover time period is a lot less due to all of the certification regarding all the products within your building system has been already thoroughly explored in the approval process. So it's fairly easy to see your MMC time saving in comparison to your traditional site build project, where working with traditional building methods, you will have unexpected risks. You'll have weather conditions. A big thing at the minute is to get experienced labour and quality of labour available to carry out projects to traditional design methods. And again, the certification and handover, typically in a traditional project, is all down to the latter quarter of the project, and it creates a lot of stress for the site team. So the types of MMC in use today in construction in Ireland generally. So I've split this into the 7 definition categories for modern methods of construction. So firstly, the 3D primary structural systems. This would be your offsite volumetric buildings. Typically, this is largely used in schools and in commercial settings where you're putting in fully volumetric finished buildings. Category 2 is the 2D primary structural systems. This would be the offsite light gauge steel systems, timber frame systems, precast systems, so on. Generally, across Ireland at the minute, it's light gauge steel and timber frame building systems that are used in most of the residential projects that are being carried out at scale. Category 3, pre-manufactured non-systemized components. So these are growing seemingly on a daily basis, where you're getting your precast piles, precast ground beams, column floor slabs, staircases, and individual components. There's efforts made from a lot of Irish companies there at the minute to manufacture as much elements as possible off-site. Regarding the additive manufacturers, this would be the 3D concrete printing. It's not really commonplace at the minute yet in Ireland, but there are a couple of Irish companies such as HTL that will be bringing it to market fairly soon, and looking forward to working with the system on site. Category 5, the non-structural assemblies such as bathroom pods, utility rooms, M&E assemblies. These are growing usage, and typically in apartments in a lot of our sites are being used there at the minute. It really speeds up the finishing aspect of a large-scale residential project. Category 6 would be the traditional building product optimization. So this is simply just taking our traditional building methods. So it'd be taking a look at, if we're using an insulated panel system and having all your materials cut off site, just trying to shorten down the on-site process of the original site process based product. And category 7 would be site process optimization. So using BIM integrated into all the design of your building project in collaboration with lean construction. We've rolled this out across all our sites at the minute, and it's presenting with the BIM clash analysis. It brings up any issues before they become reality on site. And with lean construction, it's transferring the great productivity on the factory floor to an on-site setting. So just going to look at the current strategies employed by OCC at the minute. So we've invested significantly in MMC in the past number of years, just aiming to maximize capabilities of the latest technology in materials and MMC. And this has led on to us forming our sister company, Greenstone Structures, a light gauge steel manufacturer also based in Galway. So as I said previously, we constructed a prototype housing estate in Kinbarra. It was the first passive housing estate in the West, but we also wanted to learn from the different building types. So first half of the estate is light gauge steel, or is insulated concrete formwork, and the second half of the estate is the light gauge steel framing. And we also have timber frame projects currently ongoing as well. So we wanted to carry out research to see which would be the best way forward for us. And what we're finding to date is with light gauge steel, from 3 to 5 stories, that's the sweet spot where it's on its own, from a cost and productivity point of view. Similarly with timber frame, from 1 to 2 stories across the board, that's the best scenario for that. And with insulated concrete formwork, so it compares relatively the same as timber frame from a cost and productivity point of view, but generally it rolls down to the availability of resources, so the shortage of skilled labour and block layers, that makes the final decision between timber frame and insulated concrete forms. Regarding lean construction on site, so there probably 2 years ago we rolled out the last planner lean system, which really organised every site the same across the board, whether it be light gauge steel, timber frame, or insulated concrete form. It breaks down the processes into very simple planning system that every member of site can visualize and can understand. And since we carried that out, we've been maximizing the productivity of everybody on site in comparison to the guys in the factory. So from our recent projects, there are a couple of challenges and learnings as we evaluate them at the end of each. So number one would be the design for manufacture and assembly philosophy. So greater collaboration between the contractor design team at plan stage would allow the most efficient design approach. So input, the sooner that the contractor and your structural system provider can liaise with the design team, the better. So this really narrows down the design process pre-construction, and just allows the greatest efficiencies to be achieved by all. Number two would be design freeze. So we found that the more time we put in pre-construction to getting all the stakeholders together to review every single aspect of the building, the better. So a day in pre-construction, pre-design freeze stage is worth exponentially 4 times that on site as any issues. But the more information we can combine into a clash analysis before construction happens on site, the better for all involved. Regarding structural systems, so I could run through this already. Basically, timber frame ICF for the first for 1 to 2 stories, and light gauge steel for above 3 stories. And item number 4, there'd be continuity and repetition. So as we've experienced there across numerous projects in the past couple of years, the amount of time is put into fully designing out and developing each building and starting from scratch on the next project. If there was greater if there's greater repetitivity across different house types across projects, it would make a massive difference to MMC suppliers, as you can take trusted and proven designs that have been completed, all design issues have been fully taken away and designed out, and repeat them. And I think that's the greatest thing that could maximize output there in the coming years. So I'm just going to run through a brief case study. So this is our prototype housing estate in Clonmacnoise, Kinbarra and Galway. So this is a light gauge steel frame, which it's a greenstone structural system. We're NSCI certified. So as you can see on the right, you've all your wall panels complete and standing in factory and ready to be delivered. And on the left, all site services are complete, boundary walls complete, the roof structure is erected and ready to be installed. Day 1 on site, all your external walls of the bottom floor will be erected and on the internal walls. As you can see, there's little to no manual handling from the guys on site. Day 2, see the floor cassette system lifted into place. Completely designs out the risk of standing floor joists and working at heights on site. Day 3, all the external walls and internal walls to the first floor erected. And day 4 and 5, the truss roof is lifted into place along with the gable ends. And on day 5, both blocks are removed weather tight. Overall, we're very happy with the results of the project in Kinberra, and it gives us a good overview of different building systems. We found for speed, light gauge steel provided the best outcome. But typically in the use, it is used for duplexes and apartment blocks. From a cost point of view, it is more efficient. And that is all for me. Thank you for listening.
So we have just one more presentation, and then we'll go to the Q&A. So last presentation is by Professor Brian Broderick around design for manufacture, assembly and disassembly. So over to you, Brian.
Okay, so hello everybody. As Jamie says, I'm Brian Broderick. I'm part of Construct Innovate, and what I'm talking about today really stems from a small research project I did with John Hickey and Trinity within Construct Innovate on design for manufacture and assembly and its relationship with MMC, and also how that connects in with design for disassembly and also design for reuse. Okay, so the MMC definition framework that John went through and gave examples of all those different categories, and that tends to focus on physical elements, the modules, the panels, the pods, and some materials and some processes. But there is very little emphasis within that framework on the processes that are required to facilitate the inclusion of those components, building elements within building projects. So where we have building elements being manufactured off-site, like the ones that John just showed in the video, for example, that they require to be integrated with each other, and they require to be integrated with in situ elements on the site. And that means that you're going to have to use site methods, and you can see the cranes, etc., in John's videos. But those site methods are going to vary from one project to another. Each site is going to be different, each house is going to be different, and the way that the contractor proposes to go about doing that will be different. So you really, in contrast with some other industries like regular product manufacturing, in construction projects where we're looking to avail of MMC, we really have a lot of project-specific challenges, which means that every project, every development has to be taken on its own merits. But what we can talk about is enablers. We can talk about things that help us to apply MMC. And this is where the FMA fits in, the design for manufacturing and assembly. But it's just one process enabler that allows us to employ MMC. So BIM is another process enabler. Lean manufacturing is another process enabler, just cleverer ways of doing things. And then we have technology enablers as well, mostly centered nowadays around data, but in other forms of technology as well. So that's where this concept of design for manufacturing and assembly fits within construction, and in particular within the MMC framework. So if we look at what design and manufacturing and assembly actually is, it's a concept that grew out of the manufacturing sector right back in the 1970s, and there are two parts to it. There's design for manufacture, DFM, and design for assembly, DFA, and you can imagine what happens. What each of those refers to. Design for manufacture is about the making of individual parts of a machine, or in our case, it will be a building, and design for assembly considered how those two things went together. So those emerged as different concepts, and they've been put together. In the construction sector, design for manufacturing leads to designs for buildings, housing in our case, that enable specialist subcontractors, maybe an offsite manufacturer in that sense, to manufacture significant elements of the design. And the design for assembly then considers how each of those can be put together on site in a way that minimizes the amount of work to be done on site. So because it integrates really naturally with MMC, DFMA has come to be regarded as a facilitator and enabler of many MMC approaches. And has arisen some amount of confusion or overlap between the usage of different terms. So sometimes people talk about DFMA when really what they're talking about is MMC. You saw when Aileen put up a slide and referred to what's happening in the US, they don't use the word MMC. They use prefab a lot more. They use offsite a lot more. So in this talk, I'm trying to stick to the concept of design for manufacturing and assembly as a design approach and to a certain extent a project delivery approach, rather than thinking about the physical elements that go into making up the building themselves. So these are some general principles for design for manufacturing and assembly. And as I said, these arose or generate mostly in manufacturing and product manufacturing. You can see the list of them there, the goals to reduce manufacturing time and cost, reduce assembly time and cost, reduce handling time and cost. And there are rules or guidelines or principles that the designer should try and adhere to under each of those headings. The goal of all of those, the principles together, is to achieve the type of behavior that you see in the graphs on the right-hand side. First of all, economies of scale. Everyone knows you think more of something, you can usually do it cheaper and get a better return that way. But more interestingly, the diagram on the bottom right-hand side shows that as the number of parts that are included in a product, okay, so it might be a product like a car, in our case, it'll be a house or an apartment building, as the number of parts that you have reduces, the greater the amount of savings that you have. But at a certain stage, those savings will drop off. So there is an optimal number of parts to get the balance between the cost of manufacturing an individual part and the cost of assembling lots of different parts together. So that process has been really very well fine-tuned within the manufacturing sector. And that's possible there because generally they're working in much more controlled environments, producing the same thing over and over again, and everything tends to take place in one location. Even something as complicated as a car, say, for instance, you could consider it that way. And the details then that people go into in terms of, for instance, just in terms of the handling of parts, you can look at the symmetry within a part that's going into a component that will be part of a whatever it is you're trying to produce, a product. And the greater the amount of symmetry there is, then the less handling there is in the manufacturing process. So design for manufacturing and assembly is quite a well-developed and finely tuned activity within some manufacturing industries. Within construction, as I mentioned earlier, because each project is so different, it means that really that level of fine-tuning doesn't really apply or can't be availed of. So what we can imagine in this context is the goal for DFMA is to enable increased MMC adoption in construction. And it does that by integrating together the different phases of a project. So the design phase, the manufacturing phase, and the construction phase. And the little drawings there show how traditionally those might have been separate, and within DFMA, we try and integrate them all together. So it is a form of integrated project delivery in that sense as well. DFMA building for buildings then anticipates the use of specific MMC components. So the designer has to think about, okay, I'm going to use the type of concrete walls that John showed in the diagram. I'm going to use a 3D volumetric modular unit, and that's going to become an important part of my building. The designer then thinks where and how will those be manufactured off-site, and then the designer also has to think how will all of those things be put together. Now, no one person is going to be able to do that. So again, if you contrast it to DFMA in a manufacturing factory, you can imagine a designer working in that place for a number of years. They will understand the full process. They will understand everything that goes on in that factory. They will have all the information together. A construction project isn't like that. An architect is not going to know what's the optimum way to manufacture a component like a 3D volumetric unit. Somebody else is going to have to advise on that. And neither of the people responsible for that are really going to be the experts in how the whole thing is put together on site. So it's much more of a team activity that becomes important than integrating together and starting the process early. In particular, the interfaces between the MMC components and the traditional building elements or other MMC components themselves actually need to be planned out really well. And so the component manufacturers then need to be involved at the early design stage. You can't just design the building and then hope that later on you'll have some component that will fit in naturally and perfectly. So closer integration of the project phases is required, and closer integration of the people, the stakeholders that are involved is also required. And that integration actually can be facilitated really well through BIM and other enabling technologies, like where we store information, how we communicate with each other. So RIAI, the architects, have looked at this very carefully and produced what they call the DFMA overlay to the plan of work. So the plan of work divides up the construction project into a set of different stages. And so there's a variation on that standard set of stages has been produced by the RIAI, which allows DFMA, design for manufacturing and assembly approach, to be followed in the delivery and the design and manufacturing construction stages of the project. So the overlay allows DFMA principles and the philosophy of using that approach to design to be integrated within the familiar construction stage process that people are used to in the construction industry. It doesn't mean that that's the only way to do it, but it's the way that fits in with established practice. Other approaches are available, and especially when we have what's called vertical integration in the project. In other words, one company is not responsible just for one of the stages, but is responsible for all of the stages. Then they don't necessarily have to follow this procedure because they don't need to partner up in the same way. So as well as identifying those stages, the plan of work also gives guidance on the design development in the early stages, but also related to sustainability and digital delivery throughout the whole process. Even with that standard process agreed and set out, there's a lot of challenges to DFMA in construction, and we can think about within the research project that I mentioned. We looked and saw that these challenges have been categorized previously under a number of different headings. So these are the headings that we settled on within the project. One relates to organizational structure, the second relates to the contractual framework, and the third relates to operational systems and processes. So organizational structure talks about the structure of the team formed by the project stakeholders. So the stakeholders are the developer, the designer, the contractor, everyone who's involved in the project, the client at the end, the household owner at the end probably as well. But really in the project, the team that they form and the timing of their collaborative engagement in the project, who needs to be involved, where and when. The contractual framework then, it talks about the way in which we align the stakeholder goals with the overall project objective. So the different stakeholders coming in have got different goals that they want to achieve, but if they all have to be aligned together coherently to make sure that the whole project is completed in the way that it should be. And that's where compensation structures come in, but also risk allocations come in as well. And the allocation of risk in design for manufacture and assembly needs to be different to the allocation of risk in other traditional projects. Needs to be greater sharing of risk. And then the third one is operational systems and processes. So these are the tools and the technologies and the mechanisms that allow us to collaborate and communicate when we're pursuing the FMA. That would include, for instance, BIM. So within the project, by looking at what other people had published, by looking at interviews that had been carried out with people who are working in the industry, and looking at publications from some of the high-level groups that Aideen referred to in her presentation, we were able to identify really quite a long list of challenges to DFMA under each of those headings. And I won't spend too much time going through each of those, but there's a report out there pretty soon that you'll be able to read all of those. For design for disassembly, we also looked at this as well within the project. So there's kind of an alphabet soup of DFs has emerged. So there's design for manufacturing and assembly that I've been talking about. There's design for disassembly, which happens at the end of life of the building. And then there's associated with that, and that's really what we looked at more closely, is design for reuse. So once you disassemble a building, what are you going to do with the different parts that you have? So the flow chart there shows the process, the life cycle of a building, from the resources that go into it through the construction, the use of the building, its disassembly at its end of life, and then what happens then to the different parts you disassemble them. You could relocate the whole building in a new location. That happens sometimes with temporary structures. You can reuse the components as they are. You could reprocess the materials that the components are made out of, make them into different components, or you can recycle the materials back into their original state and turn them into something completely different, not even a building. So disassembly is the essential first stage for all of those reuse, processing, recycling activities. And it stands to reason that if we are planning for design for manufacture and assembly, that it should also be possible to include in that an element of planning for the disassembly stage later on in the life of the structure. So, and indeed, when you look closely at the principles for design for manufacturing and assembly that I showed earlier, and the type of principles for design for reuse that we look at in the report that we've written, you can see that there is quite a lot of overlap. So simply the modular nature that's often of a structure that's often associated with design for manufacturing and assembly, on the face of it, would seem to lend itself really well to disassembly later on in life, and that's true. So the design for manufacturing and assembly, which can facilitate MMC adoption and especially modular structures, can in time facilitate design for disassembly and ultimately design for reuse. But there are some really important design for disassembly and design for reuse principles that are not part of design for manufacturing and assembly. So one is in the layering of building components, so that the building is constructed with a series of layers that allows you to take away the layers one at a time at different times if necessary. That's not part of the design for manufacturing assembly at all. So compared to the really rapid expansion that's taken place in recent years in MMC related activity in Ireland, both on the ground, as John showed, and in sort of a policy arena, as Aideen was talking about. Compared to that, in the sense of MMC, there really is very little happening in the country related to design for disassembly and design for reuse. And we need a program for research and knowledge transfer and getting up to speed on that for the industry, because there are sustainability obligations coming down the track really quickly to do with the life cycle assessment of buildings. And we really do need to improve our level of knowledge throughout the whole industry on how design for disassembly and design for reuse can help us with that. Okay, I think I've probably gone right as far as I could possibly go. We're right up against the time, so sorry about that, but I'll leave it there.